Okay, this is the design of experiments template from the ASQ website. Just going to go over real quick how to use it. In this case, it's a 3-factor, 2 levels. So you got 1, 2 levels, 1, 2, 3 factors. So how many different combinations can we have? It'd be 2 to the third. That's 2, 4, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we got to do 8 experiments. In this case, they randomize the experiments so that we can spread the noise out. Say temperature is changing over the during the experiment. You want to spread that out over the randomize that a bit. That's what this run order does. So the way you use this is you'd come up if you got 3 factors that affect your process or inputs to whatever it is you're doing. You want to put those in here. In this case, our 3 factors are boost, moist, and cycle. These are the actual settings we'd use. Boost would be the low setting 45, high setting 90, 6, 10, 11, 6. And then we come up here and we'd actually do the experiment. The first one we'd do would be this one right here. We would set the boost at 45, moisture at 10, cycle at 11, and do the experiment and record our results. In this case, we did it twice. There's our average. Come here to the second experiment. Boost is set at 90, moisture at 6, cycle at 11. Run our experiment, take our results. And again, this will tell us what to do. If you populate this, it'll self-populate our table up here. So what happens is it calculates for us. Excel's got some macros in this. So factor A, you can tell the effect is a 4.95. B, 1.825. C, 3.275. And here's where I do experiments like this. DOE, we got the interaction 8 by B. And the effect of that is 4.55, right? So what that tells us then is we got to be careful. Impulse will be, oh, okay, we'll just change A, but no, you can't do that because it'll interact with our B, which is the moisture. We got to worry about this interaction here. So we got to realize we change 1 because the interaction with B, it changes our results. So you can't just change 1. You got to worry about this interaction. C, A by C, B by C, 3-way interaction. Not much effect there. But our 2 big hitters. Third factor is C. Not much interaction with C. We do whatever we want for C. Pretty much not worry about it because of these low interactions. So we can see that, right? How they calculate it. Now here's the interaction, right? The way we plot this is I'm going to set A low, which is the boost, low, which would be the 45. So all the 45s go in this column. All the high, the 90s, go in this column. So then I'd come back and I'd say, okay, what about the B? Well, in this case, it's moisture, right? So I'd say, well, what about the low? And I'd put that on. Here's all the B lows. Here's a B low at the high. And I just plot those. If they cross, you have an interaction, right? It's good to see graphically. We used to do this by hand. This was very helpful. But I'm going to tell you, just go up to this here, and I'll tell you already. This is the table, the graph you want. There's A by C. Again, they're parallel. They don't cross. Not much interaction. Let's look at B by C. It's even less. Even more parallel. And that 3-way, they can't graph that. I don't think they tried to. No. You can graph it, but it doesn't mean much. But you've got 2 graphs. And you try to get that third dimension in there. But that's it, right? So here we're telling us A has the biggest effect. And then this interaction between A and B has the next effect. And then C. So we can fine tune this, right? We can do our settings and get the results we want.